The team begins the design process by researching precedent and knowledge sources, detailed descriptions of existing USGBC certified projects. Next, project information, such as zip code, project type, and size, is sent to the USGBC. The USGBC responds with a list of possible LEED credits customized for the project. Clear iconography illustrates each LEED category, indicating how many points have been achieved in each category. The research team adds a carbon icon, which tracks credits that contribute to reducing the total carbon footprint of the building. Credit goals are set to yes, no, or maybe. An additional set of indicators shows which credits are calculated directly from the building information model. The team tracks intent, requirements, and strategies for each credit in a next-generation version of LEED Online. Energy and atmosphere. In conceptual design, the comparison of the evolving design against a benchmark is critical to achieving prescribed energy reductions. An interactive ability to track shadows for each sunpath yields insight and improves decision-making. Solar studies provide feedback while the team sites the building. The team considers the impact of important site conditions, such as mature trees and an existing water tower. Comparing different schemes against one another provides knowledge about trade-offs. The schematic energy meter shows comparative energy analysis for different options. Indoor environmental quality. With the model more developed, additional analysis can be performed and acted upon. In this scenario, the daylight analysis view shows that the project hasn't achieved daylighting LEED goals. Increasing the window height brings more light into the workspaces. The simultaneous aggregation of this rich set of information, the model, color-coded plans, LEED credit listings, scores, and graphic analysis, enables designers to observe cause and effect directly. 2 daylighting credits are achieved, but at the expense of losing an energy credit. The project team brings in a daylighting consultant to provide alternative design strategies. The interface allows multiple means of making contributions. The consultant sketches a design directly onto the interface, suggesting sun shading devices to block out direct solar gain and also bounce light deeper into the space. Horizontal and vertical louvers are added to the model, reducing total energy consumption while maintaining the 2 daylighting credits. To further improve energy efficiency, the designer experiments with glazing alternatives, such as low-E glass for the south facade. When the effect of decisions on LEED targets and potential points is immediately evident, sustainable design insight improves. The system indicates the project is tracking well against the set goals for energy and indoor environmental quality. Water efficiency. Additional credits are also considered, such as water efficiency. The team considers several different strategies to reduce reliance on municipal water, such as capturing water from the roof and retention areas around the site to reduce stormwater runoff and for reuse. The research team looks at quantities of water which could be collected in a given month. Historical weather data provides accurate estimates for designated areas in the model. Increasing the retention area allows the project to rely heavily on gray water and reduces the need for municipal water. Stormwater runoff is also decreased. The model is now used as a direct link to a product marketplace, where more efficient fixtures are located, compared, and used directly in the model. Using low-flow fixtures throughout the building reduces the amount of water the building will use. Materials and resources. The focus now is on tracking and calculating material quantities for LEED credit purposes. Reinforced concrete comprises the bulk of material used in the building. Moving a recycled material slider over the model view filters the model and shows the amount of recycled material in the concrete floors. The visual representation of this information helps designers better understand the impacts of material selections. The team changes the floors to use a locally produced fly ash mixture to gain LEED materials credits. Columns are also changed to a concrete mix with a higher recycled content. The design team considers LEED throughout the design process and moves directly to the next step, LEED certification. A model-based design process streamlines LEED validation and supports accelerating LEED registration. Throughout the BIM design process, documentation is generated and tracked in real time as the model evolves, making it much easier to track progress and documentation. The file which encapsulates the key elements of the project for validation is now transmitted to the USGBC. Once the building is certified by the USGBC, the design is presented as an example for future green buildings.